interesting. Can I ask a quick question? The diamond, you talk about diamond nanowires. What does that mean? I mean, it is the element, I mean, it is the mineral, diamond, right? Or
Yes,
is it
it's a semiconductor insulator. Okay. So
right, right.
you can cut the diamond and you can create okay. Here, you can cut the diamond using a machine, focused ion beam, which I'm not showing here because of the time limit. And do you see the size? Is that this is 0 point? Actually, this is 20 nanometer, something like that.
Right. Huh.
Yes. This may not be 20 nanometer, but 30 nanometer. But I have another picture which shows 20 nanometer.
Right.
We cannot go less than 20 nanometer, difficult, it will break. But
Okay.
you need this kind of thickness. So this will be used as the phase slip junction. That means it will stop the supercurrent, and by adjusting this size, you can control the supercurrent in this circuit, in the loop. In this loop.
Okay. Right. So obviously this depends on the molecular structure of diamond that gives you these properties.
Diamond molecular structure is it's a very good question, maybe very deep rooted question. Anyway, so actually what you see in the textbook, diamond is a cubic structure. I mean diamond structure. But if you go to the nanoscale here,
Yes.
it is very uncharted territory. I mean it can be SP2 type, it can be SP3 type. It's still people are doing research, and this research will be continuing. What is the exact molecular structure of diamond at the nanoscale? That's a very good question.
Right.
And our student, another student, Venkatesh, okay, he published a paper recently. Actually, it was published last week about the molecular structure of diamond here at the grain boundary. So it's very, very complicated. You can read, it is described more details in my book. I address this point. So we wanted to break the concept of crystallinity in diamond because it's a mixed phase. It's hybrid structure anyway.
Yeah.
If it is a pure crystal, one type, it cannot be superconductor. So you have to have a defect. You have to introduce defect and special molecular structure, and that becomes superconductor.
I see.
That particular thing is very important, not the whole structure.
Right.
Like this part is most important, not this other part. Only this part is important.
Right.
Yes.
Fascinating, Prof. Thank you very much indeed for your talk. Let me see if there are questions. There's an open question from Kenneth. Is the diamond synthetic, and can you reorganize or manipulate its properties to achieve improved or the desired performance?
This is very good question. Okay, Kenneth, I know him very well. Okay, I think, yes, this is synthetic. This is lab-grown diamond. I mean, we have grown the diamond, some of the diamonds in our lab. We have a setup for diamond, micro FCVD. However, for good quality diamond, we cannot grow in our lab. So we have to buy or get it from the bigger system. The quality matters. It is really important how good your diamonds are. Good means not a pure phase, but how you control the property of diamond. So we have been working last 20 years on diamond synthesis. Maybe more than that, maybe 25 years. Okay, I'm not that young. Anyway, so we know in and out of diamond, not superconductivity only, but semiconducting properties and growth mechanism, etc. So that inspired her to work in diamond-based qubits. It's a very difficult job, although. For example, you cannot control the NV center's position in diamond. It's very difficult. It's still open problem.
Ah,
Yes.
interesting. Gosh.
It's interesting. That's the reason we are in South Africa. And
Yes.
if we say diamond things, everybody gets interested all over the world. You are from South Africa. That means you have some interesting piece of diamond.
We know about diamonds in South
I
Africa.
sell that. I sell that point, and sometimes I lie that okay, it is from our one of our special diamond from South Africa. But these
Yes.
diamonds we use basically these are lab grown.
Okay. Well, we're good
Yes.
at that as well. Yes.
It's
Well,
interesting.
I'm very envious that you've met all these people on your photographs there, and particularly John
There are
Martinez.
many more, but I just put the recent ones. No, the selected ones. Okay. Hmm.
And you have the blessing of John Martinez, so it must go
I
well.
have little contact with him. The main problem is that he had a problem. He wanted to come to South Africa, basically in 2017, but he had a problem with Google itself. I mean, he had to leave Google and he could not really communicate with people, basically, because of the security or whatever. They have some restrictions. Hmm.
My goodness,
So
that
you
is
cannot reach him
very interesting.
easily. I mean, it's very difficult. But you cannot believe such a nice person. I mean, you cannot find this kind of person very easily. So
Yes.
down, so knowledgeable. So he fetched me from my hotel, and probably he paid for the hotel also. I don't remember. Anyway, that's not an important thing. He fetched from my hotel and dropped me off, and the whole day, 2 days, actually spending time and incredible. That kind of,
Amazing.
well, I met several, not several, few Nobel laureates like here. He's good friend of mine. I still have very good contact. He's in Singapore right now. But knowledge-wise, John Martin is, you cannot believe the knowledge. It's not just luck. He got the Nobel Prize. He deserved it. You cannot believe that person is so knowledgeable and so down to earth.
So interesting. Oh,
This is a
very
lifetime
appreciated.
opportunity.
Yes,
Okay.
for
If we
sure.
can establish any in our life, I will go and grab him. You have to come with me to inaugurate this program. That I will do first thing. That is
Get him
what.
to come and work in South
Anywhere in the
Africa.
world, if I get money and he can,
Yeah.
if I can establish a quantum computer, superconducting, the first job is to find him and
Oh,
meet
I
him.
wish you all the luck in the world.
Yes.
Wonderful.
In
Thank
fact, I will
you.
invite all of them, basically.
Yes.
Don't
Yes.
worry, God is listening to me, and sometime it will happen.
Ah, I'm watching the space.
Thanks for recording my message or my voice. Yes. Okay.
Thank you,
No
Prof
more.
Somnath.
No more. That's enough for
Okay.
today.
Okay. Thank you.
Nice talking to you. Thank you
You
very
too.
much. Okay.